Let's do an example where we use for loops to work out the molar flow rates, or the moles, of a stream of components. So what I've done here is I've written out two vectors to represent the molecular weights and the masses of a stream containing 7 components. So the 7 components are CO2, H2O, H2CH4, CO, O2 and N2. And I've gone and typed out what the molecular weights are for each of those components. And then let's assume that we have a beaker, or maybe we have a stream with components, these 7 components, where the masses for each component are given by these values over here. So for instance, 10.5 corresponds to the mass of CO2 in my beaker, and 35 corresponds to the mass of H2O. So what I want to do now is I want to use a for loop to go through each of these elements and work out the moles for the stream. So eventually I want to have a vector n that will contain all of the values of the moles of the stream corresponding to these masses and these molecular weights. So eventually I will have I suppose I'll have seven numbers for these question marks that will represent the moles in the stream. So the way that I can do this is I can use a for loop. So what I'm going to do first is, what I should always do first is, if I'm going to make a vector containing all of the elements that I want to hold values for, then I can allocate that vector up front. I can reserve space to insert all of the values into this vector up front. So I can use the zeros function, and let's say I want to make it a 1 by 7 vector. So right now, if I were to run this, let me just comment this out so it doesn't interfere. If I were to run this function, the script now, then I have 3 vectors that I've created. So the first is m, small m, which represents my mass of my components. Capital MW is my way of representing the molecular weights corresponding to those components. And you'll notice that both of these are row vectors that are 7 elements long. So the key here is that there are 7 elements inside these vectors. The third vector I've created is my zeros vector, which is going to hold the values for n that I want to work out. So the way that I want to work out n now, let me clear the screen, is by using a for loop. So the first thing I want to do is create my for loop. So I've written for I, and if I'm going to run for 7 elements long, then I need to change this number 5 to the number 7. I need to change that to a number 7 because I want to run from element 1 all the way up until element 7. If I put element 5, I would only go up until the 5th element of my 2 vectors, and if I put something like element 9, then I would run past the number of elements, the maximum number of elements in my vector. So the number that I must put in here is 7 because I know that there are 7 elements inside my vector. The next thing I want to do is now I want to work out the molar quantities of CO2, H2O all the way up until N2. So the way that I can do this is I first notice that if I type m brackets 1, I know that m is a vector, and so m brackets 1 is a MATLAB instruction to say return the first element of this vector m. So if I push enter just in the command window, then I get 10.5. If I put m of say 3, then that will return the third element of my vector m. In this case, if m is my vector and I'm wanting to return the third element, then I should return 45. And yes, indeed I do. I return 45. The same goes with MW. MW of, say, 6 is the 6th element inside my row vector MW. So that's 1, 2, 3, 4, 5, 6. It's 32, corresponding to O2. If I push enter, I get 32. So if I were to do this manually without a for loop, then what I could do is I could say N1 equals m, small m, 1 divided by molecular weight 1. And that's my moles just for CO2, my first element. Now if I wanted to do the second one, I could type N2 equals m component 2 divided by the molecular weight for component 2. And I get a number. Now I've got to do N3. So I do m brackets 3 divided by mw brackets 3. And you can see how this becomes quite tedious because I've got to do this 7 times. If I had a stream containing 50 components, 50, then I would have to do this 50 times, and it would get quite tedious. And it's not something that I should be doing like this. What I should be doing is using a for loop to repeat all of these common tasks for me. So you notice that for N1 I used the first element of the m vector divided by the first element of the molecular weight vector. For N2 I used the second element of m and mw. For N3 I used the third element of m and mw, and for the 7th element I would use m7 divided by mw7. So what this means is that there's a pattern to all of these that I can use to work out my moles in a for loop. And the way that I can do that is I notice that the variable I is going to run from 1 to 7. And so I can use I to index. I can use I to retrieve the elements inside my vectors for me. So what I mean by that is I can write n I is equal to m I divided by mw I. Right, and maybe I should put this after the comment just so that it makes more sense. Okay, and so what I've instructed MATLAB to do here is to work out the ith element of my n vector, and the value of the ith element of my n vector will be equal to the ith element of my m vector, my mass vector, divided by the ith element of my molecular weight vector. And this is interesting because I've used a for loop to do this 7 times for me. So even though I've written this once, I've written it with respect to a general looping variable I that will go and repeat this calculation 7 times, and for each time work out m over mw and insert it into the ith element. So on the first iteration I has the value 1. That means that n1 will be equal to m1 divided by mw1. Then I end, and this loop goes around again, and now the value of I is 2. So then n2 is equal to m2 divided by mw2. I end the loop and I go around again. Now my value of I is 3, so n3 equals m3 over mw3, and so on and so on. It goes all the way up until 7, in which case it's n7 is equal to m7 over mw7. And after that 7th iteration, the for loop ends. So by me writing this for loop, just 3 lines, well 4 lines including a comment, what I've done is I've told the computer to do this calculation 7 times for me. So now just to test it, I will click run. And so what I've done is I've created this vector n, and I've populated all of the entries with the corresponding moles, the molar quantities of the components that I was trying to work out. So if I type n in the command window, then you can see now I've gone and worked out all of the values for the moles just by doing this loop. So there's no longer this thing of doing 1 is equal to m 1 divided by MW1 and so on and so on. I don't have to do that. I can get the computer to do that. And I do it by using a for loop. So for loops are a very convenient way, essential way for us to get the computer to do all of this work for us. And because the instruction for working out the fourth element for Ni is the same as the fifth element for the moles, I've got a pattern here for how to work out the moles, and that means I can repeat the same pattern, I can repeat the same calculation in a for loop and get the for loop to do all of the work for me.